let us define power. So, power, the rate of work done is defined as power, So power will be represented by the symbol P. So power is equal to rate of work done. So we call this instantaneous power because the power may be changing with time. So instantaneous power is equal to rate of change of work done, that is rate of work done dW by dt into displacement F dot dx by dt, or we can write dr by dt, that is equal to F dot dr by dt is V. So we can also say thus power may be defined as the scalar product of force and velocity. So this is power. So it is a scalar quantity. Whose SI unit is watt. So we have 1 watt is the power when 1 joule of work is done per second. So when 1 joule of work is done per second, then the power will be called 1 watt. Now, if the power is not constant over a time, then we can say that it is average power. So average power is defined as the total work done by total time taken. That is, we define as P average is equal to delta W by delta D. Delta W depend on whether the force is constant or not. We can define delta W as F dot average speed, or depending on F is constant or not. So simply I will write delta W by delta T as the average power. Now let us take some cases of projectile motion where we will see that the power generated by gravity and all these things. So now let us take the example of a projectile motion and see the power developed by gravity. So power developed by gravity during projectile motion. So you see, this is our parabolic path of a projectile in which we have projected with velocity v at an angle theta. So this O is the point of projection, and let us select some point. This is the topmost point, this point is A, and this is a general point. So let us calculate first. So power developed by gravity at the topmost point. So we have power is equal to force dot velocity. Force here is mg vector, dot velocity is actually v naught. Suppose v naught is the initial velocity, v naught cos theta along I. So you see here this becomes 0 because mg vector is downward and here velocity is here. So this power is 0. So at the topmost point the power generated is 0 by the gravity. Now let us see the power developed by gravity. The power developed by gravity as a function of time. what is the power developed by gravity as a function of time. So sorry, this is average, this is not, power is not a vector, this is scalar quantity P, so it's a blunder P. So now you see here this P power as a function of time is P is force mg dot this velocity vector, which is v naught cos theta I minus gt v naught cos theta I plus v naught sin theta minus gt along j. So this g vector is also downward, so I will write minus mgj dot v naught cos theta I plus v naught sin theta minus gtj. So you see this I and j, so we have I and j dot product is 0, so only j and j will be multiplied. So we will have minus mg v naught sin theta minus gt. So this is how the power will be developed as a function of time for a projectile motion. Now let us calculate the third point, that is average power developed by gravity during total time of flight. So total time of flight. So we see average power is delta W by delta T. So delta W we know it is 2V sin theta by G, time of flight. But work done, now work done is delta W is mg vector dot displacement, that is the range vector which is along I. This R is the range which is along this, and displacement mg is downward, this dot product is 0, that comes out to be 0. So the average power developed by gravity during the whole projectile motion is 0. So through this example we have seen how to evaluate the power developed by a force, that is the instantaneous power and the average power.